Hi all, and in today's video we are going to understand one of the most important concepts uh, in the modern AI system, which is called as the Model Context Protocol, also popularly being called or known as today as MCP. It's a term that you might have heard, and maybe at some point you might have used it also. Some of you, not most of you. So it's a quite popular concept, and today we will try to explore, what is MCP, why MCP is needed, what is the MCP architecture, the filter architecture idea, the core concepts, participants, layers, tools, and finally we will connect all this to our Python code example, right? So coming to what issues do MCP solve, right? So let's first understand the problem. So normally LLM like GPT can only generate the text, right? It cannot directly read files, access databases, call APIs, use calculators, check weather, automate systems. So the AI is intelligent, but it is isolated. Now imagine we want the AI to actually do the things, right? So you would have seen that we would have created a chatbot AI which was able to talk to you, but it was not able to touch out or touch base on any other points like a calculator or something like that, right? I do not have a real-time MCP over here, but I will try to explain it as much as possible, right? So coming back to our point, so basically the AI is intelligent but isolated. Now imagine that we want the AI to actually do the things. So read my local file, like Claude does, check the weather, query the database, create Jira tickets. So I want to create a ticket in ServiceNow, in Jira, in BMC Remedy. I want to call a REST API. I want to do the iOS upgrade on a Cisco router or a Juniper router. Maybe I want to do the iOS upgrade on the through the Aruba Central, right? So basically that is where the concept of MCP or Model Context Protocol comes in. Now it's a standard protocol that allows the AI application to communicate with external tools and system. Think of MCP like a universal adapter between AI and external capabilities. Like without MCP, AI can only talk, but with MCP, AI can act, and that is the biggest idea of today's session. Now let's talk about the high-level MCP architecture. So the MCP basically follows a client-server architecture, and then there are three main participants. The first one is the MCP host, which is the AI application itself, right? So the MCP host, the examples are VS Code, Claude Desktop, AI agents, custom chat applications. The second one is the MCP client, right? The client manages the communications with an MCP server. Usually one MCP clients connect to a MCP server, and then in the third, the MCP server. So basically it exposes the tool, resources, and prompts, right? So we talked about the three things: the MCP host, right, which is basically your VS Code, your AI agent, or the custom chat application, or the Claude Desktop. Then we talked about the MCP client, which basically manages the communication with the MCP server. So usually one MCP client would connect to the MCP server, and then third is the MCP server itself, right? So this basically exposes the tool, resources, and prompts, and the MCP is the component actually is the capabilities. For example, file system server, weather server, database server, GitHub server, Aruba server, Juniper server, Infoblox server. So these servers, you can build on a simple Linux systems. You'll have to build it like an MCP tool, and they will be able to talk to the the real Infoblox or Junipers or the Arubas of the vendor using the RESTful API approach or any other approach, right? So we ask the questions, the AI application receives this, the MCP client then communicates with the MCP server, the MCP server then executes the tool, and the result comes back, and AI responds intelligently, right? So so if I explain the filtered architecture, now let's discuss something very important. Filtered architecture is an excellent way to explain the MCP. Now the AI model should not get unrestricted access to everything. Instead, MCP acts like a a controlled gateway, right? So you can see that the MCP client is basically the part of the AI application, right? So basically here we have in the AI application or in the MCP host, we have hosted the clients. There are multiple clients, and these are talking to the MCP servers, right? So let's say I have developed a MCP host, like as I said, a chatbot or Claude, and then basically inside that we have an MCP client, like a OTP tool or something kind of a tool, which is able to talk on a dedicated connection like STDIO or streamable HTTP to basically an MCP server. So basically it will talk on basically two layers, which is the transport layer and the data layer, on which the interaction, so basically the interaction will occur on the transport layer, and data layer is something which is internal to the MCP, where it talks about the variables, what information is actually being fetched, and then based on that the server will again respond back to the client, and AI will understand, interpret it, and provide the output to you, right? So basically user to LLM to MCP client. MCP client will send it to MCP server to the filter tools, and the MCP server exposes only approved functionality. For example, maybe only read specific folder, query safe database, called approved APIs, and these creates controlled AI execution. So MCP is not just integration, it is a secure and filtered integration. Also, MCP creates a structure and filtered boundary between AI models and external systems. Okay, now we were talking about the layers of the MCP in the previous section. So they are the two layers, the data layer and the transport layer, right? So basically the data layer is an RPC communication, tools, resources, prompts, notification, and this is basically the logical layer. You can say this is the brain of the MCP communication. And the second layer is transport layer. The transport layer basically where the interaction happens between the MCP client and the MCP server, and they are basically two common transport. One is the STDIO, which is the standard input output, and the second one is streamable HTTP, right? So STDIO is mostly used for the local server, and HTTP used for the remote MCP server. So transport layer handles communication channels, and the data layer handles the semantics and the meaning, right? Now coming to the core concepts of MCP. Now let's understand the core concepts. They are extremely important. So MCP server exposes three main primitives. So the first primitive is the tool. The tools are executable functions like the calculator, the weather API, the file reader, and the database query. And tools allow AI to perform action. So this is where we implement in our Python example today. The second primitive is the resources. The resources provide the contextual data, like the file contents, the database schema, the API responses. So resources are usually read only contextual information. And the third and the most important concept is the prompt concept or the prompt engineering, where example we prompts are reusable templates, where we put a few short prompts, system prompts, and special interaction prompts which help structure the AI interaction, and you will get the output accordingly. I think we talked in the last of one of our sessions about the prompt engineering was the better the prompt is, the more complete the output you are going to get from your LLM or SLM that you have created, right? So now we are going to talk about this particular code that we are going to create over here, and I will show you the sample execution, right? So first and foremost, you need to have your VS Code, right? In the VS Code there is a env file which I have already created, and then I will be creating a MCP server, and then we are going to create the MCP client. And as we talked about in the concept, we are going to make the interaction between the the server and the client, right? So let me first write the code for the MCP server, right? So you need to remember that for writing the code for the MCP server, you need to have one very important library from Python which you need to install, and that is called as the FastMCP, right? So that is, the command is pip install FastMCP if you have the Python, and the Python that you should be having is greater than 3.10. So you should be having Python greater than 3.10, and then you have to do pip install FastMCP, right? So once that is installed, it will be there as a part of your library, and then you can leverage the FastMCP to create your MCP server, right? Now let us go into the code. So first I will do is from FastMCP import FastMCP, right? So this is the first line. Now you have to create an MCP server. So I will create an MCP server. Okay, that will be created as MCP equals to fast MCP, and then I can make, let's say, a calculator or maths kind of a server. So I will make it as math server, right? So this is the math server, and then I will take two actions I will perform, right? The first action is going to be the addition function, right? So I will do tool1, and this tool is going to perform the addition, right? So this is what we are going to do. And now I will do for the decorator, we have to use the decorator function over here, mcp.tool. We will use def add. So this is a function that I'm creating, and b colon int, okay, and I will do return a plus b, right? And then what I'm going to do is I'm going to write one more function over here. The function will be called as multiplication, right? So I'll just copy this complete function from here, and I will paste it over here, and I will, instead of tool1, I'll make it as tool2, and I will call it as multiplication. Okay, so here I will return a into b instead of a cross b, so a into b, right? So you can do that. You can write it this way, or you can write it with separations, right? So this is done. Now I have to start the MCP server, right? So what I'm going to do is let me do this, start MCP server, right? And we are going to start the MCP server. Okay, so if underscore underscore name is equal to main, right? And this is the one, let me make it double quotes, sorry, yeah. And I will do MCP dot run. Okay, so this is what we are going to do. Now the MCP server has been the MCP server has been created, right? So okay, so now let me make you understand basically what this particular this thing is doing, right? So what is MCP server doing, right? So when I talk about the MCP server, basically we created an MCP server, right? So when we write MCP is equal to fast MCP Math Server, this created an MCP server with the Math Server, right? Then we registered the add function as an AI callable tool, and then we did the same for the multiply. And when we run mcp.run, then the server starts listening to the tool request, right? So what we are going to do is let me open this, one of the command prompts. You have to go to the MCP server, right? Since I am using a lot of Python Python versions, so I'll have to type which Python, right? uh, Sorry, I'll have to do, just give me one moment. Okay, so yes, I'll have to do which Python. Oh sorry, it's where Python, sorry, my bad. I thought that this is Linux, but no, it's a Windows server. So I'll be getting the modules that I am basically using. So I have to use greater than this one, right? So I'll be using this Python 3.14, right? So what I'm going to do is I'm going to copy this, paste it over here. Sorry, my bad, I did not copy it. Yeah, now I copied it. Now I'm going to paste it, and I'm going to simply do MCP underscore server dot py, and I'm going to launch it now, right? Meanwhile this launches, let us complete the client application also. Okay, so I will write the MCP client. So I'll do import OS from .env. Sorry, my bad, I wrote it in the same line. From .env. So basically .env is load your variables which are present in the environment. The env file I showcased it to you. For security purpose I cannot disclose what is the environment file that I'm using. So it is going to be like that. Now I will do load underscore .env, right? And then I'm going to use the OpenAI. So because I'm using it as an you can say an AI host, right? Just like your Claude, this I am using is the OpenAI, right? So OpenAI, right? Now I'm going to load the .env file. So basically my the open API key that I'm using, I'm going to use that to leverage that, right? So I'm going to load the .env file. I'll do load .env, right? This is the command, and then I'm going to create the OpenAI client. Okay, and then client is equal to OpenAI followed by API key that is equal to, one second, that will be equal to os dot get env. Let us check whether the MCP has been launched or not. Now you can see that MCP has been launched successfully, right? It has been launched on 17/5/2026, right? So basically the MCP server has been started. This is the current MCP version that I'm using, which is a part of the Python module that we are using right now. Now we are going to load this file, and we are going to load it as open API key. Okay, so I'm going to write it like this. It will be open API underscore key. Okay, so this is how it is going to be. You can keep it like this. You can do it like this. One second. Yeah, API key is equal to os dot get env open API key, right? And once this is done, you can go to the print statement. I will type in the print statement. I will write MCP AI assistant is ready, right? And this is the one. I'll do a slash n. Then I'm going to type print type exit to quit. Okay, then it will be the same kind of a while loop or uh, flag based approach, where until unless we quit it internally, it will keep on asking you the questions, or you can keep on asking the questions as a client, and the server will keep on answering you. So while true, what we are going to do is user input equals to input followed by you can put user over here, and this what questions you are going to ask, that is the one. Now if user underscore input dot lower equals to exit, right? So you have to break it. Let me put it in double quotes. Okay, now that's done. And now we are going to ask AI. Okay, what that will be the response. So response is equal to client dot chat dot completions dot create. Okay, and in that I'm going to use the model equals to GPT 4.1 hyphen mini, right? So this is the one. Then I am going to give the messages. That will be your message, and in that I am going to put up a role. So role will be inside this. Yes, it will be a user. Sorry, so my bad. User, and then content is going to be user input. Okay, I think that's about it. So then I am going to do the print AI. Print response dot choices 0 dot message. I did not closed it. I should have closed it. Message dot content. Okay, and then simple print. Okay, so let me save it first. Let me have a look. I did the import OS, then from I imported the environment variables. I imported the OpenAI, then I loaded the environment variables. Then for the client OpenAI, I did the API key where I'm getting the environment variables of the OpenAI. Okay, so my key is not correct. OpenAI API key. Then I set the MCP. Sorry, MPC. I'm writing MPC. MCP model context protocol. AI assistant is ready, and then type exit to quit. While true, user input. Let me do it you because it might interfere with the one of the variables that I'm using below. So if user input dot lower equals to exit, then break. Ask the AI to response is equal to client dot chat dot completions dot create, and model is equal to GPT 4.1 hyphen mini. The message is your role will be user, and you will be typing the user input, and then you will be getting the response, right? So let's try this. I have saved this. Let me save it, and then let's try to run it. So I have opened another one. So what I am going to do is I'm just going to copy what I have run already earlier, but instead of MCP server I am going to run the MCP client, right? So just copied it. I'll paste it over here and I will put MCP client. Okay, let's see. Okay, so let me type hi. Okay, so let me ask, give me the addition of 347 and 542. Okay, is 889. Okay, now if I want to multiply 347 542, what will be the answer? Right, so you can see this is the answer. What functions the MCP server can perform? So it's not able to understand it, but yeah, definitely it's the model context protocol. But anyways, it's not able to understand that, but yes, it is able to perform the two functions that we talked about. Right now, the term when we talked in terms of prompt, it was not able to understand that. But yes, if I talk about this, uh, let me write model context protocol. Let's see, we are trying this just like a wild card, but I don't know if it is going to give an answer or not. Right, okay, so let me check. uh, okay, so right now we can see that the client is just talking to the MCP server. The MCP server has popped up, and it is trying to bring up the questions and probably the answers, like what you can do, what you are capable of, what is the MCP server, what is the you know the MCP server, what it can perform. But yes, other than this, we were able to perform the addition and multiplication. Now let's try whether it is able to perform the subtraction also. Okay, it is able to give the answer, but the specific function that we have written, it is only able to respond with that. Right, so basically this is the MCP server. The client is basically talking to the MCP server, but MCP is also leveraging the AI, which is also able to add to the queries that we have added to. Right, so that's what it is. Right, so let's go back to the you know uh, our point where we were continuing. Right, so we talked about the MCP client and the MCP server concept that we created. Right, please note that this is not a very real-time MCP server, but this is a sort of implementation that I wanted to showcase to you for the MCP server. The MCP server also leverages the AI functionality as well, because the AI is able to interpret and respond to the particular MCP server. Right, so in the host, basically, which is your AI server, the MCP tools are basically discovered. So there is an important MCP feature which is called as the tool discovery. The AI does not hardcode tool. Instead, it asks what tools are available. So this happens, using the tool list. The MCP server responds with the metadata, for example, tool name, tool description, and input schema. Then the AI decides, which tool to call, and this is a very, this is very powerful. The AI dynamically learns the available capabilities, right? Now, let's understand the runtime execution that we did. Now the flow is, the user says add 5 and 10, right? It adds it and it provides you the answer as 15, right? So basically what happens is that I should use the add tool. The MCP client sends the tools call to the MCP server. The MCP server executes the add function and then it returns it. This creates intelligent action execution. Now, the notifications and the dynamic system. So another important concept is the notification. So MCP supports real-time updates. Suppose a new tool becomes available, so the server can notify the client, and the client refreshes the available tools automatically, and this makes MCP tool more dynamic, right? So if you are adding any real-time concept inside the MCP server, right, uh, and basically, once it is being grasped by the MCP server, the server can notify the client, and the client refreshes the available tools automatically, right? So now let's summarize everything. So basically, MCP is a standard protocol for connecting the AI systems with external tools, right? So you have the capability to not only generate a text or a reply, but you can even ask the Junipers, the Arubas, the Ciscos to do the work. Uh, as I talked about earlier, the iOS upgrades and configuration push, configuration comparison. These can be done on the networking based environment. Not only that, but other applications can also be accessed to the MCP servers. It introduces basically a structured communication, a secure integration, tool discovery, execution workflow, filtered access, and scalable architecture. The major concepts which we talked about was the host, the client, the server, the tools, the resources, prompts, data layer, and the transport layer, right? And in our Python example, there was an at the rate of MCP tool, right? So it is the mechanism that converts the normal Python function into AI usable tools, and that is the foundation of modern AI agents. So today's AI systems are moving on the generate text to perform intelligent actions, right? And MCP is one of the major technologies enabling that transformation. uh, so that's all from my side for the model context protocol. I hope that this has been an informative session. uh, if you have any questions or points related to the MCP, or if you want to know more about the MCP or the implementation, please do put out the comments in the comment section and let me know. And I hope this has been an informative session, and I will meet you into the next session with some interesting topic. Thank you so much.